Okay, section 1.6 video, part 2. And in this particular section, we're going to look at solving radical equations. Now, I trust you know whenever I talk about a radical is like, that's the radical symbol. In this case, this is called the square root, like square root of 16. That symbol right there is called the radical symbol. We're also going to have equal signs in the problem, and you're also going to have a variable in the problem. So, just to give you a couple of visuals of a radical equation, don't write these down because we're going to work these in just a few minutes. This problem right here is a radical equation, and we're solving it for x. Or, this one right here is a radical equation, and we're solving it for x. So basically, we're going to be solving equations where your x is under the square root. Okay, so before we get to that, let me give you your steps to solving radical equations. 4 steps. Here are the steps. Step 1. Isolate the radical term on one side. Step 2. Square each side and simplify. Excuse me. Square each side and simplify. Step 3. Solve the remaining equation, which will be linear or quadratic. And then step 4. We must check the answer in the original equation to determine if it is a solution. Okay, I will explain these steps as we go through. Let's do 3 examples here. The instructions here, solve the following. Solve the following. Let's call this example A. Okay, here we go. Step 1. Get the radical term on a side by itself. It is. So there's nothing to do on the first step. Second step, square each side. And simplify. Now remember, squaring and square roots undo each other. We learned that with the square root property. Equals 16. Step 3, solve the new equation. Add 3 to both sides to get x equal to 19. Step 4. Now, let me mention this here. One of the things that makes a radical equation different than many is this. Sometimes in radical equations, but it doesn't happen all the time, you get what's called an extraneous solution. It's basically a false answer. But it doesn't happen every time. And there are things that causes it to happen that I'm not going to go into. But every radical equation that we solve in here, notice I didn't circle that answer. We have to check that back in the original problem before you touched it plug that number back in and see if it makes it work, see if it makes it true or not. Okay, so if we've got to check it, back in the original problem, write the original problem back down. Now we're checking to see if 19 is the answer. So put 19 in X's place. Now when you're checking, plug the number in and do the math. You don't square both sides. We do that when we're solving it. When you're checking it, do the math. So 19 minus 3 is 16, and the square root of 16 is 4. That is certainly true. So that means that the number that I checked made my equation true, which means that that is the solution to the equation. Okay? Let's do 2 more examples here for this section. Now, make sure you learn your steps. Step 1, isolate the radical term. Okay, is the radical term by itself? No, it is not. I've underlined the radical term, but notice you've got this term right here with it. I want to get this on the side by itself. To do that, you have to subtract 3 from both sides. Okay, so that's step 1. Step 2, square both sides. Now, why do we do that? Because when you square that square root, it gets rid of the square root. Now, when you square negative 5 times negative 5 is a positive 25. This is step 1. This is step 2. Now, step 3, solve the problem that's left. Add 1 to both sides to get 26. Divide by 2 to get x equal 13. Notice I did not circle it because I'm not 100% certain if this answer works or not. So let's write the original problem back down. When you check your answer, you plug the number in for x that you're checking. You don't have to put it in parentheses, but to me it looks better if you do. Now don't move the 3 over. Just do the math. Don't follow the 4 steps in solving. When you're checking, just plug the number in and check it. So 2 times 23 is 26 minus 1 plus 3 equal 2. Do the math. Square root of 25 plus 3 equal 2. Square root of 25 is 5 plus 3 equal 2. And 5 plus 3 is equal to 2. Well, no, it certainly is not. 8 is not equal to 2. So that means then that the number that I'm checking didn't make the equation be true. That's false. So that is not the answer. Well, I don't have any other answers available, so this problem apparently then has no solution. But see, had I not checked this problem, I would have had no way of knowing that that problem was actually no solution. Okay, let's do one more. This one, same steps, but it does have a little bit different twist to it. We won't get far into it at all before you'll see the difference in this one. Okay, let me put this one back up. I just now noticed my video was saying low power mode. So if you missed this one, copy it down right quick. Pause the video if you didn't get it off the video. Okay, now I'm fixing to slide it up and show you the rest. No, I'm sorry. That was not the one that we just did. Here it is right here. But don't worry with the scribble marks. Just copy the problem. If you haven't already got it, this was my camera messed up just then, and I'm not certain if the video messed up. So let's go back to this problem. If you didn't get it, if you did, bear with me and let me run through it again. Step 1, isolate the radical, so we move the 3 across. So that becomes -5. Square both sides. When you do, you get 2x minus 1 equals 25. And then add 1 to both sides, so you get 2x equal 26. Divide, you get 13. But when I wrote the original problem back down and I plugged 13 in to check it, it ended up being a false statement. So for that reason, this problem was no solution. Okay? All right. Now, sorry about that mess. All right, let's do one more. This one right here. As I just mentioned, this one has a little bit different twist to it. Okay, let's go through the steps. Step 1, isolate the radical term. Well, it's not by itself because you have the adding 6 here. So what I want to do is I want to subtract 6 from both sides. One of the things that quickly makes this one different is, where in the others this was 2 numbers that you could add together, you can't add or subtract these together. So that's one thing that makes it different. Step 2, square both sides. This is the next thing that makes it different. When you square the left side, that is easy. But when you square the right side, and you have to square both sides, this is where we usually make our mistake. Because what a lot of students will do is they'll say x squared plus 36, or x squared minus 36. That is not how you square this. Let me come to the side. This is my scratch work. Remember, if you take x minus 6 and square it, what you have to do is you have to write it out twice and do the FOIL method. So this is x squared minus 6x minus another 6x plus 36, which is x squared minus 12x plus 36. So when you square this binomial right here, you get a trinomial. So let's put that in here. X squared minus 12x plus 36. Okay, so what was the first difference? You can't subtract these together. What was the second difference? When you square this binomial with this x in it, you have to do the FOIL method. Now, here's the third difference. Look at what kind of equation you have. This is a quadratic equation. Remember, to solve a quadratic equation, it has to be set to 0. So, I want that x squared to stay positive. So what I'm going to do is leave what's on the right side over there, and then I'm going to move this x over, or subtract it from both sides, and then subtract 14 from both sides. So I subtracted x, subtracted 14. Or if you say move it over, I moved both of these over so it would be set to 0. Now collect my like terms. Minus 12x minus x is minus 13x. And then 36 minus 14 plus 22. Now, this is a trinomial. This is the easy case. X squared, x and x, signs are the same, both negative. Two numbers that multiply to give you 22, but if you add them, you get 13, is 11 and 2. Now take and set both of these equal to 0. To get the two potential answers. And the key there are potential answers. All right, now what do I have to do? I have to check both of these. Now before I do this, let me say this. I don't have any clue what's going to happen. They could both work. If they both work, I have two answers. If one works and the other doesn't, I have one answer. If neither one of them work, I have no solution. So there's no way of predicting what's going to happen until I check them. All right, so let's write the original problem back down before you touched it. Now, I'm going to try 11 first. So this would be 11 plus 14. Every place you have an x, put 11. Now, do the math. Square root of 25 plus 6 equals 11. Square root of 25 is 5 plus 6 equals 11. And that's true. So that means that x equals 11 is one answer. Now, if the other one works, there's going to be two answers. If the other one doesn't work, just one answer. But it can't be no solution now because that one worked. Now, if this one had not worked, don't write no solution till you check the other answer. Okay, let's write the original problem back down. Now let x be 2. Every place you have an x, put a 2. Square root of 16 is 4. No, that does not work. So that means I can mark that answer out. So this problem had one solution, and that one solution is x equal to 11. Okay, so this completes section 1.6, video part 2. So all we have left is section 1.8. I would expect there to be either 2 or 3 videos there. And then shortly following that, I will be having your midterm. I will make up your final exam review for you as well. So, all right, this concludes these 2 videos.